Terrific. So I just want to welcome you to this talk, which is Objects as Software. This is Zach Hoken-Smith. He's the director of the RepRap Research Foundation. He's the creator of the Sanguino, which is a derivative of the Arduino. He recently wrote all the software behind the Thingiverse, where you can share digital designs. And he is, of course, a founding member of New York City Resistor, which I'm a member of, and we call him Sir Awesome.
I paid her to say that. Okay, well, thank everybody for coming. I'm really excited to talk to a captive audience. This is going to be fun, especially about something that I really, 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 really love. So, which is digital fabrication. To get started, a little bit about myself. Like Max said, I like to start lots of new things, so I'm always like making some new thing and probably leaving something else unfinished, but I'm sure that's a common problem here. I started the RepRap Research Foundation, which is a not-for-profit that is designed to help do research and support the open source RepRap project, which is a 3D printer that makes copies of itself. Along the way, we needed a more powerful microprocessor, so I was like, well, I'll take Arduino and I'll throw in a bigger chip, and the Sanguino was born. And likewise with Thingiverse.com, we have all these designs for digital objects, and we really have no good place to share them. So I was like, well, I'll make Thingiverse and have a place for all my friends to upload their digital designs and have a place for other people to download designs and make them. And NYC Resistor is a place where I learn, share, and make. It's a nice little hacker space in downtown Brooklyn. And if you want to get a hold of me, there's my email. I get way too much email because I always put it up and give it to lots of people, so I'll try and respond. So first, a disclaimer. I really love this stuff, and I play around with it a lot. And today, what I'd like to present to you is my dream for the future. There's no guarantees in life, and I'm certainly not psychic, so who knows what will happen until it actually happens. However, this dream that I'm going to talk about is shared by many, many people. And these are hardworking, smart people, and I think that together we will achieve it. So keep that in mind. So the core topic of the talk today is digital fabrication. And I'm not really going to go into the technical details of this because it's all over the internet. If you want to learn how stepper drivers work or control boards or G-codes or any of the like awesome nitty-gritty like super nerd cool stuff, the best place is the internet. What I want to talk about is the why and the passion of digital fabrication. Like, why am I here today, and why are there so many people that spend hours working and tinkering on these machines? So if you're not familiar with digital fabrication, it's basically computerized manufacturing processes. So machines like CNC machines, laser cutters, all sorts of machines that make physical objects but are controlled by computers are digital fabrication machines. It's all about taking the human out of the actual loop of producing things. I think it's going to change the world, but the revolution is not going to be televised. It's hard to put a time frame on it, but why not? 10 years. In 10 years, the revolution will be downloaded. You'll either design your own stuff and then make it with your machines, or you're going to download someone else's design and then make that. Most likely it'll be a little bit of both. Who here, just raise your hand if you wrote Firefox. Nobody? Not even a patch? But who here has written a little script to do something that, you know, fixes a tiny little problem you have? Probably quite a few of us, you know? A little like glue, Perl script, something like that. So in the future, I imagine it'll be a little bit of the same thing. So you might download a cool open source project that, it's like a toaster or something, but if a little plastic cap falls off on your car's radiator or, some sort of fluid tank, then you make a custom one and use it, and life goes on. So someday, you'll have a machine that will make you anything you want. Yes, I'm talking about the Star Trek replicator. No, it won't be perfect at the beginning, but by the very of a machine that builds parts, you will have the tools to upgrade it yourself. You'll be able to bootstrap yourself into better and more advanced electronics. I call this the automation age. Throughout the course of human history, we like to classify the nature of our technology into the materials and things that define this age. We've had the Stone Age, the Bronze Age, the Industrial Age, the Space Age, the Information Age, and now we're going to have an age of automation where you can design something and then a robot will go out and do it. Obviously, this age will be marked by automation of physical processes as well as the distribution of that technology to your average human. The distribution is the crucial part, because without giving it into the hands of every person that needs it, then it's just closed off and walled off, and it's inaccessible. The Stone Age wouldn't have been called the Stone Age if there was only a small group of humans who had access to stone technology. It's about getting this technology out to everybody that wants to be a part of it. You might also be able to call it the robotics age, but I think that might come after the automation age, when people are using these machines to build robots, Jetson style. But I lied. It's actually already here. A huge amount of the things that you use in your day-to-day life are actually made either wholly or in part by digital fabrication. CDs and DVDs that you use to install stuff are written and stamped by automated processes. The computers and electronics that I'm using to talk to you today are made with automated photo plotters, CNC machines, pick-and-place machines, and all sorts of these automated tools that build electronics. Same thing with just random consumer goods. Even the crappy plastic toys that you can get are usually made from molds that are cut by CNC machines. Books are another example. These things are made by automatic printing processes. And even something as simple as a shirt is made on highly automated machines. It's only really in the final step that humans sew them together into a shirt or a shoe or so forth. But it's not really here. I'd like to do a quick poll of the audience and do some stuff. How many of you have regular access to a CNC machine? That's a good amount. That makes me happy. How many have regular access, like you could go use a laser cutter within an hour? What about a 3D printer? Maybe 10 of you. What about a normal inkjet or laserjet printer? Yes, awesome. What about a computer? So basically, all of you in here have an 80s supercomputer and a printing press that would make Gutenberg's head explode. So to put this all in perspective, just a little mental exercise here. This computer, I think, has a 2 gigahertz dual-core processor in it, which I'm guessing probably translates into about 4 billion calculations a second. On a good day, I can probably do 2 calculations a second maximum. The computer does that many, many, many times faster, and it does it with 0 mistakes. It's not going to say 2 plus 2 is 5, but I might. The core lesson to come away is that when you automate these simple tasks, it drastically reduces errors, and it drastically increases the speed at which you can do them. To bring it back to digital fabrication, with the CNC machine, which is basically just a Dremel on a 3-axis, you could maybe do 1,000 millimeters a minute. A human on a milling machine might be able to do 100 millimeters a minute. So in this example, the CNC would be 10 times faster. It could run 24/7, no need to sleep, no need to eat, no need to drink. You'd have to, I guess you might have to feed it new material, but not the same. So essentially, digital fabrication is better, it's faster, and it's stronger. And so the thing here is that digital fabrication is just using very simple tools, a Dremel in the case of a CNC machine, a hot glue gun in the case of a 3D printer, a laser in the case of a laser cutter, and like a plasma torch in the case of a plasma cutting machine. They're controlled very precisely by computers. This is the real revolution, is adding that intelligent precision control that you can automate. The automation of simple tasks like this, like cutting a slot in this part or moving this glue gun and having it extrude at a constant rate. This automation of these simple tasks allows intelligent beings, us, to work at a higher level. My friend Archimedes said, "Give me a lever long enough and I shall move the world." We're extending that lever as we speak. There's a few metaphors that I found to be very useful when I think about this technology and when I talk to people about it. I come from a software background, so I grew up writing programs and code and stuff, which I think a lot of us share that background here. So I like to draw parallels between the world of software and the world of hardware. So the first one is your designs that you make. So like a design for a laser cut pump is the source code for that object. So if you change the digital design, you change the actual physical object. So you make a change to the design, you send it to your fabricator. In my example, I like to use a laser cutter. So send it to print, and it laser cuts it, and then you have a new object, but it's based on that original source code. An interesting thing about this is that it's possible to dynamically generate objects. Since it's just a digital file, you can very easily write a script that will generate that file that you can then, in turn, give to a friend. My friend Kelly wanted some display boxes, and she needed them to vary based on the different things she was going to put in the slots to display. So she wrote a Python script that generated a file, and then she could just easily generate a new display case that's completely customized to her needs. Also, as we all know, source code, digital files are very easy to share. The cost of bandwidth is pretty much free these days, especially with sites like Google Code, SourceForge, GitHub, and Thingiverse. You can just upload your files, and they'll send them out to other people for free. Finally, you should not make anything manually ever again. As programmers, we work at the level of source, and we have a compiler make the finished product. Hopefully, most of you don't code in hex. So why would you cut and drill holes into a board when you can have a machine do it for you? So the machine itself, I like to think of as the compiler. You have a machine, and you feed it some sort of digital representation of a real object, and then it transforms that design into a real physical object that you can hold, or a binary. So you have your source code, it takes it, crunches it down, and it turns it into something that will run on a computer, and then execute your instructions. To me, at least, it's essential that this part remains open. If you can't hack on the thing that makes your things, then you're going to be severely limited if you ever run up against something that you can't solve. So the ability of this thing to be hackable and for you to get in there and modify the inner workings is very crucial. And ideally, if your compiler can compile itself, then it allows you to self-upgrade and bootstrap yourself into the next generation